Going over final test, test number 4. Create a while loop that will print the even numbers from 100 down to 2 inclusive. We need to start off with while, of course, and I want to go from, what did it say again here? 100 down to 2. Well, I need some sort of counter variable. I'm going to call this I, set it equal to 100 to start with, while I is greater than or equal to 2. There we go. I'm going to print I. And now I need to adjust the 100. I want to go down to 2 and only evens. So that means I need to subtract 2 each time. I minus equals 2. We'll subtract each time. I'll have 100, 98, 92, so forth. And it'll keep going down until it reaches 2. It'll print out the 2. It'll go down to 0, and we'll drop out of the loop. Just to check to make sure that works. I've started at 100, and I've gone down to 2, inclusive. Create a for loop that will print the numbers from 1 to 100 inclusive. For every multiple of 3, instead print fizz. This is actually an adaptation of an interview question that's fairly common called the Fizzbuzz interview question. It's a little bit harder than this, but something you might see on an interview. Okay, I need a for loop for, what do I want to start with? 1 to 100. For I in range, I'm going to start with 1, and I'm going to go up to, but not including, 101. That loops from 1 to 100. Now I want to print I. This will print from 1 to 100. However, every multiple of 3 instead print fizz. Therefore, I need an if statement in here. If I, how do we figure out if it's multiple? We use the modulus operator. If we divide by 3 and our remainder is 0, remember how that modulus operator works, I'm going to print fizz. Otherwise, I'm going to print the number itself. Run this. There we go. 1, 2, fizz. 4, 5, fizz. 7, 8, fizz. 10, 11, fizz. We could do it with any multiple just by changing that number. Write code that will take a price from the user, then print the price, a 20% discount, and the total sale price after the discount. Take a price from the user. That means I need an input statement, so I'm going to do price equals input. Now I'm going to need to do some sort of math on this, which means I probably need to convert it to a number. And in order to do that, I'm going to use the float command and take whatever we've entered, turn it into a floating point. Print the price. Well, that's easy. Print price. A 20% discount. Discount. Well, I can just do print price times 0.20. And the total sale price after the discount. Print price times 0.8. Because if I take 20, the discount would be 20%, 80% would be the price that's left over, giving us a total of 100%. There's several ways you could do this. You could, for instance, instead do discount equals price times 0.2. Total equals price minus discount. And then instead print discount total. This will give us the same exact thing. Really kind of a matter of preference as to which you prefer. Prints the price, $16 discount, and $64 would be the total. Write 2 for loops that will print a box of asterisks, print a box of asterisks 10 wide, 7 tall. For I in range. The outside loop is going to control the number of rows. How many rows? 7 rows. for j in range 10 columns. Print an asterisk. I need them to be printed on the same line, so I do this end equals 0, or end equals double quote, double quote. I could use a space in here if I wanted to space it out a bit. And then once it's done with this particular row, let's print a blank line. It needs to be tabbed in, lined up right here in order for it to work. There we are. Write a function that prints your favorite cartoon character. There we go. If we wanted to print Snoopy, that's all there is to that problem. I didn't ask you for do an input statement. I didn't ask you to have the user specify the favorite cartoon character. Just print your favorite cartoon character. Call the function in the prior question. Don't forget those parentheses. That's all there is to that problem. Write a function that returns your favorite G-rated word. This will return high. You don't need parentheses around high at all. And if you want to print the result, you're going to need a print statement down here. Print f. This will call the f function. It'll go up here. It'll return high. Therefore, this will be replaced with high, basically, and it will print out high. There you go. Write a function that takes two numbers and returns their difference. A little bit of a trick to this one. Here's a function. Takes in two numbers as a parameter. I need to do their difference. Let's do d equals a minus b. Important, don't have this variable be the same as your function name. That's just weird. It kind of works, but it's not a good idea. And the issue is, though, if b is larger, my number is going to be negative, and that's not, you could return d, but instead I'm going to do an if statement here just to make it all the better. If d is less than 0, I'm going to say d is equal to d times -1. That'll make sure that I've got the absolute value of d. There are other ways you could get absolute value, like use the math library. There we are. That'll take two numbers, return the difference. Always being positive. Write code that defines a class called book. Give it one attribute, one method. Class book. Book should be capitalized. Give it one attribute, one method. Pages equals 0. By default, we'll make it 0 pages. And one method, def open. All methods must, as their first parameter, have self. There are some exceptions to that, but we don't get into that in this class. And in this case, I'm going to print open. You need to have something in here. You can't just have the function definition with nothing in it. There we are. There's a class called book, one attribute, one method. Write code that defines, okay, we've done that. Write code that creates an instance of book. B equals book, b.pages equals 340, b.open, open close parentheses. Don't forget those because otherwise it's not a method. That's all there is to it. We don't want to use book.pages or book.open. Remember, we need to actually point to the book we're talking about. Write Python code that will create an array of 100 zeros. Stuff to do with lists. I need to start with an empty list. There we go. Then you can do a for loop for I in range 100. And I'm going to do list.append 0. This will take an empty list with 0 zeros, and then I will loop 100 times, each time appending a new 0 to that list. Write code to print the second value and the last value. Alright, if I want to print my list, I need to have this, and I want to print specifically the second value. I might be tempted to do 2 here, but I don't want to do 2 because lists start numbering at what? 0. Therefore, number 1 is the second value in the twisted world that is computers. Next, I'm going to print the last value. There's 2 ways I could easily do this. I could count them up, or I could use the -1. Either way works, although -1 really doesn't work in almost any other language. Write code that would print the cell that contains the number 1 given the following grid of numbers. Let's assume that the variable name is called grid, because I don't tell you in this question. Grid 1. Row goes first, row 1, column 2. Grid 1, 2. That was easy. Really, you need to demonstrate that you can show how to access a 2-dimensional array, one specific cell out of it. Write code to swap the values 41 and 55. Should take you 3 lines of code. Alright, I need a temp variable anytime I'm swapping, so I'm going to use t for my temp variable. T equals list 0. That will take the item out of list 0, stuff it into t. Then I can modify list 0 without worrying about the original value being replaced. And I wanted to replace it with whatever 55 is. 0, 1, 2, 3. Then list 3 is going to equal the original value of list 0, which I've stuffed into t. There we are. 3 lines of code in order to swap 2 values in a list. Under what circumstances would a linear search well, but a binary search would not work at all? Make sure you phrase this right. Linear searches still work if the list is not in order. Binary searches must have the list in order. Short answer, if the list is in order. Show how to perform a selection sort using the following numbers. This is easier to draw out than type out, in my opinion. Okay, I've got this. I need to do the next iteration through the loop. I'm going to select the smallest number and swap it with the first item here. Therefore, this will go over here. This will go over here. Drawing the arrows isn't strictly necessary, but it helps visualize it. Okay, next one. Well, it's in place. Yay, I don't need to do anything there. Next one. I need to swap this with the 2, because the 2 is the next largest. 0, 1, 2, 5, 4, 3. Then the 3 is going to be swapped. 0, 1, 2, 3, 4, 5. Probably the most common mistake people make when doing this is to do the insertion sort. Really make sure you get those 2 straight, because if you've gone through all the work of understanding how it works, don't lose the points in the question because you mix up insertion and selection sort. Next up, show how to do the insertion sort. Okay, we start with a sorted list right here, and we insert this guy. So this guy will go over here. This one will shift up into position, 1, 5. Next, we add this guy into the loop, and the 1 will stay where he is. The 4 will go here, insert it into place, and the 5 shifts up. Next, we'll insert this guy, 0, 1, 4, 5. Next, we insert this guy, 0, 1, 2, 4, 5. Insert this guy. 0, 1, 2, 3, 4, 5. There we are. Insertion sort. Write code that will take input from a user and then convert it into a number. Print an error if the conversion fails. What do you need in order to do that? try catch. So try n equals int input number except print There we go. That's all there is to it. 4 lines of code. If you already know how to convert the number, that's part of it. You need to do the try except in order to finalize how this code works. Explain what each of the circled items do. Make sure that which item you are explaining is clear. Item number 1 here, if I were to go down here and then label it, that seems to work best to making sure what things are clear. This is the selection sort. And min pause. Basically, min position right here is the position of the smallest value. It's not the smallest value, but it is a position of the smallest value. We start position of smallest value as the first item we check. Then the next part of the loop will basically go through the list in order to find any smaller items. For a position in range, current position plus 1. If we've got a list right here of numbers and this is sorted, we start looking here for the rest of the items. We say that this is min, and then we start from the current position, but there's no need to start here. We just looked here and we're going to start right here. Some sort of explanation that you are going to start looking from left to right, which is a bit odd because actually the comment here says scan left, and really you're scanning from left to right, so that comment isn't all that good. At any rate, that's what we're looking for. We are taking a look here at the current position, and it's starting at the next unsorted item to the end of the list. Be 2. Whoa. 2. Item number 3. If the list at the scan position is less than the list at the position of the current smallest value we have, that means we found a new smaller value. Therefore, 3 right here sets the position of new smallest value. These 3 lines do the swap. That swap code should look familiar. In fact, you could kind of use this swap code to answer one of the prior questions. The swap code swaps the current position with the smallest value. Anyway, hopefully you'll write something a little bit better than what I've got there, but that's the idea of the different circled items. The insertion sort starts with 1 rather than 0 because we assume that the first item, if we have a list of numbers like 5, 8, 2, 1, we start with just this guy and we assume that's a sorted list. Because there's only one element, we know it's in order. Therefore, the new item that we insert is going to be at item position 1. Starting element of the items that we will insert from 1 up to, but not including the length of the list. Key value equals list at key position. This is the key, the item that we are going to insert into the list. Key position is where it's at. Key value is the value of it. In this case, position would be 1, value would be 8. 0, 1, 2, 3. Next up, I've got this list. Okay, as we do this, as we scan, really what ends up happening is that I keep shifting numbers up. So if I've got a list of numbers like 2, 3, 5, 6, 7, and I'm inserting a 4, I will shift the 7 up, shift the 6 up, shift the 5 up until I figure out where the 4 goes. Therefore the 7 will go here, 6, 5. Anyway, this shifts items up so we have room to insert the key value into its correct location. This takes us and scans further over to the left, and this right here is what will take the 4 and plop it into its proper location over here. So that puts it, the key value, into its correct location. Write code to format the following variables so that they print something like the following. Okay, I want to print amount 1. Then my value is going to go here, and I'm going to have A1. This is a start, but I need, instead of a comma here, because I'm using print formatting, this needs to be dot format. Then, in here, I need formatting info. I need a colon, followed by the width of the field. How many characters here? 1, 2, 3, 4, 5, 6. Looks like 6 characters. 6 characters, a decimal, 2 more characters, and it's floating point, so I need an F. Then I have a $sign that goes right here. Oh, and I need to pass the format method the data that I want format. All right, let's see what this actually prints out when I run it. Lo and behold, that looks to be about what I want. Maybe there's some extra spaces in here, but I'm not going to get too picky about that. This gives you the idea of how those numbers should look as they're formatted out. So be able to do some basic formatting using the information out of the formatting chapter. Explain the relationship between Microsoft and IBM in the mid-'80s. Where did Apple get their idea from the GUI? In fact, almost everything that was really cool about computer science came from the spot where Apple got their idea for the GUI. Laser printing, Ethernet, object-oriented design, all sorts of awesome things came from that. It's like the mecca of computers and technology. You should really make sure that you understand the answer to this question. Explain the relationship between John Sculley and Steve Jobs. Give 2 points of information about the history of the internet shown in class. How on earth are you supposed to find this info? If you go back to the book, you'll remember way back in chapter 2, I said you should watch some videos and that there would be questions on the final on those videos. Looking down, here are 3 videos that cover the beginnings of the personal computer market. They're awesome videos. Highly recommend that you watch them. And down here, this actually covers the beginnings of the internet. And I'm just trying to ask some general questions that you should be able to answer if you watch those videos. So you want to make sure that you've got those videos at least partially watched or skimmed. Certainly you'd probably want to watch them all, right? At any rate, you want to make sure that you've got some of the info on those videos for the final test. And while there are no questions on it on this example test, it's also a good idea to know something about recursion, since we had an entire chapter dedicated to recursion. What is recursion? Remember, recursion is any time you've got a function that calls itself. In this case, if I ran this function, it would do nothing but generate an error because, well, it won't do anything at all because I haven't even called f yet. I call f, and f will call itself, which will end up calling itself, which will end up calling itself, and eventually crash because it ran out of stack space. What I need to do instead is have something that will stop it from continually looping. In this case, I'll use a variable. And as long as n is greater than 0, I'm going to keep looping. This will do a recursion that will start out at 10. So I do f of 10. It'll come up here. It'll print 10. Is 10 greater than 0? Sure is. We're going to call f with 9, which will come up here and print a 9. Is 9 greater than 0? Yep. Do it with 8. So forth. And you should know that recursion is used a lot in documents, file structures, anything where you can have an object basically placed inside of another object. It is a really powerful feature, also used a lot in searching and sorting, different types of algorithms for that, for fractals, if you're modifying if you're displaying vegetation, that type of thing. So know a little bit about recursion as well.